So we have 4 great panels here. I'm a very strict moderator, by the way. I'm very particular about time. So I already sent the questions to all of you except Tarun. So I might have changed the questions, so don't be so sure it's going to be the same questions. Okay, the topic we're going to talk about today is transforming careers with data science. So we're going to start off with making some statistics. The World Economic Forum forecast in 2020 data analysts will be high demand in companies around the world, and IBM confirmed this and said there will be 700,000 new recruits by 2020. That's a lot of jobs. So let's take it from the academic first. Do you think this would happen?
Absolutely. I mean, in fact, there is no doubt in my mind that data scientists, as we call this conglomeration of people who come from computer science, artificial intelligence, statisticians, database specialists, people who are working in the ERP space, all of them are coming together to basically integrate data from various sources and essentially make it available for improving our, the way we live in various different ways. So definitely, I think maybe it's an even underestimation, basically, in terms of the number of people that we need. Actually, every time I work with people in industry, every technology and even non-technology organizations seem to have a very, very strong focus on data science and the application of AI. But the challenge really is on the academic front. Are we really producing people who are capable of actually delivering this requirement? Because as I've said before to my students, that one of the challenges is basically in the integration of various elements of data science. And hopefully, as academicians, basically, we should be able to meet that challenge. And actually, Virginia Tech is going to be involved in that in a very big way. And we are basically building a $1 billion campus in Northern Virginia to meet some of those needs and requirements.
Okay, going to Rajan, since you hire lots of these people, would you agree with this sort of a focus? Or is it bad news for you?
No, it's good news. I mean, the bad news might be because of the competition for talent. But one of the things that a nuance I would like to point out is there is also a definition of what one would call a data scientist, because there's a fairly broad spectrum of definitions that might apply. What might be a data analyst to somebody might be a data scientist to a different person. A third person might view them as a citizen data scientist, as somebody embedded in the business, but who also has an appreciation of data, right? So it's kind of like a little difficult to say where that 700,000 number therefore comes from in terms of what the definition would be. But one thing I can concur with Dr. Sen is that there is a huge amount of opportunity, right, in terms of what we can do with the data. And therefore, if you're able to train people, if you're able to inspire people to take up roles related to data in some fashion, that can contribute to a great deal, right, in terms of how we are able to improve the way we live, right, as Dr. Sen pointed out. So, and this will apply in all walks of life. So it is an exciting time for companies like us, because we see that there is potential out there in terms of what can be done with the power of data and analytics, and therefore it's heartening to note that campuses and institutions such as Virginia Tech are now coming to the fore in designing, implementing, and executing programs that will help people appreciate all of this stuff. So to that extent, we are very happy about the development.
Okay, cool. I'm not going to ask the other two the same question. I'm going to now ask Pradeep. I'll ask the doctor first. Do you think data analytics is going to help you in your work area?
I think without question. Data analysts in my profession are called physicians, surgeons, and epidemiologists. We're just the end users. One of the common scenarios that we face day in, day out, and dozens of times a day, is we get a patient, they present with a particular set of problems. We have to analyze that data to say, is it disease A or disease B? If we go down the path of disease B, we could be wasting time and they could die. If we go down the path of disease A, same thing again. Now, if we had access to metadata to say, well, actually, you know, if they've got disease A plus, if they've got problem A plus problem B, this is likely to be disease B, go down this path. And this is going to increase your post or your pretest probability, and you'll save a life right there. And this is a problem we face dozens of times a day.
Pradeep, I know you run a data analytic company. Do you think data is useful for you?
That's, I think, more of a rhetorical question. The answer to that is yes. I mean,
When I ask you that, because a few years back, people used to talk about big data, big data, big data. You don't hear that word anymore. So now the big word is data analytics. So are we going the wrong way, or are we going the right way? What are we doing?
like Rajan said, big data fits in somewhere into that umbrella of the data science, data analysis, however you refer to it. But we work with enterprises globally across various industries, and every single interaction we're talking about there is about the value that organizations are deriving from data analytics, starting from your sales, marketing, operations, risk, people, all functions in an organization. Significant benefit to be had from data analytics, smarter decision making, more efficient systems, better risk management across the board. Not a single industry which is left untouched. I guess early days it was about more of the financial services, banking, these guys, but today industries which you would not associate as much with, let's say, maybe mining, agriculture, education for that matter, significant amount of impact from data analytics.
Now going back to Rajan, already the professor said he's trying hard to make his students fit into the system. So what would you, as a data analytic company, looking out for these skill sets, what kind of a role, skill set, profiles would you like him to churn out?
Yeah, it'll depend on what's the experience of the candidates that we are looking at. I mean, so when we go to engineering campuses, for example, right, engineering college campuses or science campuses, when people have just obtained their first degree, the most important thing that we look for is the curiosity and an aptitude for problem solving, and the interest in saying that let me take a structured scientific approach to that, because data and analytics is really about saying that I won't take gut-based calls, but instead I will actually use the power of data and do the right type of analysis on that in order to solve those problems. So that curiosity and that interest in leveraging data is what we look for when we're talking about somebody who's just passing out of campus with their first degree. If you're looking at a more experienced hire, and we're looking for someone with a second degree, for example, there the focus shifts somewhat to an appreciation of the domain that that person has spent time in. Now I'm connecting it back to the VT model that we talked about. That depth that's provided by the vertical bar of the T, that becomes an important aspect of what we look for, because typically every problem that we solve is contextualized within a functional area and in an industry, and in several cases a combination of both. A supply chain problem in the retail industry could be very different from a supply chain problem in the oil and gas space. So therefore it's important for the person to come with a depth of understanding. So when we look for people, then we also try and assess the person on what's the depth of understanding that you have of your domain, and are you able to connect that with the data and analytics and the approaches to problem solving that will help address problems specific to your context and your domain. So that's really what we look for.
Okay, Prerna, in this context, do you think academic institutions could design a program in particular for doctors and healthcare providers. Would that help?
Personally, I think absolutely. I think physicians in particular and healthcare specialists are the sort of laggardly group of people that have sort of cottoned onto this really late in the game. We've used data scientists to analyze papers, but what we really need are people who are curious enough to ask the right questions and to create programs around asking the right questions. And that's one thing that we don't have right now.
So, Dean, there's something that you can look at and run a program, and Pranav could be your first student.
Well, again, like I said, it's always a challenge to do this, and the reason is, actually, I'll go back to a very old paper that someone by the name John Dearden had written in the 60s, and he basically said that MIS, see, at that time it was called Management Information Systems. MIS is a mirage, and the reason he said that is it is extremely difficult to find a person who's truly an expert across the discipline, basically. And here also the same problem occurs, basically. So your background might be in medicine and you're an expert in that particular area. But in order to bring all these things together, you not only need the medical expertise, you need the technology expertise, you need the ability to be able to handle large volumes of data, and on top of that, you need to be able to handle basically the absorption of different kinds of models, whether it's for machine learning or statistics and so on. So, so what we try to do is give you the different elements of the puzzle, essentially, and to bring in the domain expertise, we really need help from the domain experts, basically. So I think it'll continue to be a challenge, but I guess academic institutions are there primarily to meet these challenges. So generally, there has to be more stronger collaboration between industry and academia to achieve these things. And just to make a plug, basically, the programs that we offer, especially in the certificate environment, I depend a lot from people from industry to be able to teach, essentially, because otherwise I can't get the domain expertise. We are not domain experts, basically. So that's in short, the challenges that we are facing. But we are trying to address them.
Pradeep, you run an analytic company. Who is the largest outsourcing data analytics country in the world? If it's India, why and how?
It certainly is India at the moment. I think the natural inclination of, I think all of us have grown up with our parents pushing to study math, and technology is a very, very big part of education growing up for us. So the talent arbitrage definitely plays to our advantage in many ways. I think we've been, I think Latent View also is in a similar space. Rajan, you might want to add something here.
Yeah, sure. I think the advantage that India has is that it has also been at the forefront of the IT revolution in some space, right? Because a lot of the
That would be my next question, that we're shifting from IT to data analytics. Is it again because the cost effectiveness here, or is it because we have better talent? What is it?
I see it as an extension rather than a departure and an inflection point, because if you look at when India came into prominence, connecting it back to the earlier question, it was with the Y2K problem, right? Everybody would remember those days when the Indian pure plays, like the Infosys and the Tata Consultants, they became bigger, started getting bigger, was really in solving the Y2K problem, right? Now, if you look at the heart of the Y2K problem, that is also a data problem. In some sense, the formatting of data itself, right? And that's where it all began for India as an IT revolution. I think we had the misfortune of being governed by the British for a very long period of time, and that did give us the advantage as an English-speaking nation. But I think the last 20 years, in terms of the skills and the capability that has been built by a very large population of people who have gone to college and studied and come out during those years, just in terms of understanding information technology itself, provides a very strong foundation for why India is and will continue to remain a destination from a data and analytics perspective as well. Now, to address the other part of the question, there have been several waves. I mean, there was Y2K, and everybody was working with mainframe systems in those days. Then client-server technology came on board, and then there was that wave of replacing mainframe systems with client-server systems. Even now there are mainframe systems, but a huge shift happened. And then from then on, you moved on to ERP, right? Everybody was doing custom-built system, and everybody did and enterprise resource planning and SAP and Oracle, right? These were the talk of the day. More recently, right, we have seen the shift to big data and now data and analytics. This morning there was this news about UiPath. I don't know how many of you saw that on UiPath's valuation and robotic process automation and stuff. And earlier when we were standing and chatting before this event began, we were talking about how today we are only scratching the surface in terms of understanding and evaluating data about manifest behavior of people. Be it a customer who walks into a shop and then is using a series of a process to decide what they want to buy. We only see what they do. We don't today know what they're thinking, right? Tomorrow there will be possibilities around that as well. I mean, we were talking about how wearables like Fitbit and Garmin and others will start providing information and data about emotional states of people, right? There are organizations like 23andMe, for example, in the United States, which actually help look into your genetic makeup, right? And whether there is a predisposition for a particular behavior or a particular disease even, right? And those kind of data will become available, and the possibilities are endless. I mean, whether you're talking about an individual as a consumer, as an employee, as a patient, right? In any of those different avatars, everybody is trying to move towards what I call the customer segmentation of one, meaning that I want to try and understand that individual in all their uniqueness, so that everything I put in front of them, right, be it a product or a service offering, or be it how I help them learn and skill up, or whether how I solve their mental and physical health problems, everything is tailored to that person. So I think potential is phenomenal.
Okay, Pradeep, most companies are now having this data analytic vertical within their organization. Do you think they should go out and hire data scientists, or should they train people within their organization with, like upgrading skills, like programs like some of these people have done today? What would be your view on this?
Yeah, so if you look at for any data analytics driven program in an organization to be successful, there are like few components which come together. If I have to pick 3 kinds of skills that need to come together in a team to make an analytic or a data analytics program successful, one would be, hey, there needs to be expertise in the team which is core to the business. Understanding what is my business, what are we achieving, where is the problem, what can be done to address the problem. If I move the needle here by so much, how will my end business outcome move, etc. A core business skill set, number 1. Number 2 is the more of the data engineering things. Like how do I handle this volume of data? Hey, is it I need to take decisions real time? How will this work? How will I connect all the analysis to where it finally gets consumed, etc. Then the third one is, let's call it the data science part, which is, hey, how do I mine the patterns? What algorithms do I use? How do I draw the insights? All of that. So if I look at these 3 things, the first one on the business part, people in the business are best suited to take this up because they've been in the business for a while, and it doesn't make a lot of sense to suddenly start hiring people from outside who will teach you about your own business, right? People in the business who can develop an appreciation for data science would be the best place. Second part is the data engineering part, which is, again, every organization has pretty substantial IT departments, and there's some very strong data professionals in it. Again, they are very well placed to take on the data engineering roles. So with a little bit of cross-skilling, they can, a good number of those roles can be filled, but some of them need to be hired. The data science part is the more complicated part. It's not like, hey, I can read up something quick and then suddenly I become a data scientist overnight. It takes substantial effort to go into the depths of understanding how do I mine patterns from data. So which means, hey, as an organization, do I have people with that inclination who can spend that amount of time, be really serious about it to develop that skills? Many organizations today are finding that, hey, it might be more easier to hire this talent from outside, and filling internally is comes second on this part. So it's a mix across the board.
Prerna, you run startups here in India and also down in the UK, and you've done some work in Boston area. Do you find it's a great struggle? I mean, we work in one of your startups doing analytics. Do you struggle and challenges in finding the right people to fit into those roles?
Very much so. I think this comes back to the initial point that you made, which is, you can find analysts fairly frequently, but trying to find them to be able to contextualize the problem, to be able to get that, again, coming down to, can they ask the right question for the problem? And I think that's where the difficulty is. I don't think that's specific to any geographical area. I think that's just going to be universal all over the world.
My next question is, what are the 3 things you would look on a data scientist before you hire? And then I'll throw the question in reverse to the professor. So maybe we start from Rajan. What would be the 3 things you would want from a data scientist?
So in some sense, I kind of alluded to this even earlier. A data scientist needs to bring the combination of the business, the math, and the technical skills. Okay, when I say math, I'm kind of putting understanding of data into it. A combination of the business understanding, the data understanding, and the technical skills necessary to execute the math algorithms that are most relevant to that particular problem is the ideal mix that one would look for, coupled with the curiosity, the problem-solving mindset, and so on. But you don't always find all of this in adequate measure in everybody, because depending on the background and the experiences that people have had, they might have one of those dimensions dialed up, and the others might be middling or even sometimes below par. But that is fine, right? As long as that problem-solving curiosity is there and the willingness to experiment and learn is there, people can be good data scientists, right? Because I think that's the most important thing that one looks for. Depending on whether, as I said earlier, right, whether we're looking at an entry-level campus pass out or whether you're looking at somebody with 15 years of experience, there are several people today that are looking to make a transition from earlier careers, right, in information technology or in project program management, or being responsible for a particular function area within their organizations. They are shifting careers now into playing a more critical role using the power of data analytics. And for these people, it may not always be necessary that they understand the algorithms and the technicality of implementing the algorithms. If they're able to get a 15,000 feet view of saying that, you know what, this is the spectrum of possibilities, but what I'm really focused on is in asking the right questions so that I'm able to tackle the most important problems that my consumers or my patients or my employees have, then you still have a winner.
Do you want to add anything to that list?
Yeah, I'll just reframe a little bit of what Rajan said. The 3 things, the business domain understanding, asking the right questions, the math, which is the quant and the analytical skills, and the technology part, which is being able to actually...
By the way, if any of you want water, please tell me. There's plenty of water there. Yeah. Just because I have a bottle, I don't want to be selfish.
And the technology part, which is being able to execute all of this, all of the great things that we are talking about, and trying to find all 3 of these in one person, that usually would be a superhuman. Not a great idea. So people would come in one of these 3 flavors, right? Like the tea that we talked about. there'll be one of these dimensions in which someone would go deep, and the other ones would be, yeah, I have a good appreciation of what it takes, and maybe I can do a few things, but it's just more about being interdisciplinary than being an expert in all. So when we look to hire, it would be, we should be at least between, the candidate should be very clear on which of these three, where is the vertical bar for them, right? Are they the business person who understands data technology? Are they the quant person who understands technology and business? Or are they technology person who understand the quant and the business, right? So clarity on how are you approaching this? Because the way the world is going, as much as there will be overlaps, but you will need to choose more or less which area you're going to build your expertise.
Prerna, anything you'd like to add to that?
When we look to hire analysts, we look to see if they understand the task, do they understand the industry, and do they understand the time frame involved in trying to get to the bottom of it.
Okay. Now, since you are training them, you just heard what they're looking for. How do you think you could help them?
So it's kind of interesting that the different functions and areas that you talked about is basically what we are trying to address through our training programs. And we have sort of looked at it from 4 different dimensions, and my colleagues are going to be really bored because they've heard this about 150 times. But so we look at that. So one component is data, right? It's all about data. Could be large volumes. I mean, generally, of course, the current challenge is large volumes of data and how do we process it, analyze it, and so on and so forth. The second component is what you call science. We basically call models, basically. The models come from different areas. It could be predictive analytics from statistics, or it could be machine learning, and so on and so forth. So that's the second area. The third area is without the technology, you can't get any of these things to really talk to each other and essentially make them work. So the third area that we focus on is the technology area. And the fourth area is basically the domain, or the business questions that you're talking about. So the science part of it is relatively easy for us because that's what we have been doing for years. And most of the science that we talk about in the industry right now, they're actually fairly old. I mean, this is really not something that's. I mean, neural networks were first discovered in this, or talked about in the 70s, and even before, basically. So, and multi-layered neural networks, which we are now calling deep learning, and so on and so forth, they've been around for a long, long time. So none of this is new. So that part is relatively straightforward. The data part is, as it relates to technology, is challenging because when it really gets to handling large volumes of data, we can talk in terms of distributed databases and distributed processing and so on and so forth, but we really do not have the resources and wherewithal to actually deploy those technologies in an academic environment and demonstrate to students basically how to use it. But we can conceptualize it and give people an understanding regarding how to handle this kind of data. And if you really look at it, what we are trying to transition from is from structured data, basically because that's really what ERP systems and so on have been involved in for over the years. But we are essentially now moving more and more towards what I would call not entirely unstructured, but somewhat in the middle, like semi-structured data, basically. So we're dealing with that kind of data, but so there's uncertainty involved in this data. So obviously, when you ask a question of this data, you don't get a definitive answer. There is always, like for example, in your profession, you can never, through say image processing, you can never basically say 100% certain that this is what it is. You might say with a 97% or 95% confidence that I can say that this is so. Or in some cases, you might say, I don't really know. I think there's a 2/3 probability that this might be the case. So there is uncertainty associated with the data. So the data part is quite challenging, essentially. The fourth part, the domain part, is actually the most challenging for us. Because, for example, when I'm really looking for someone to teach, say, fintech, or basically someone to teach, say, marketing analytics, or health analytics, and so on and so forth, we have extreme difficulty finding those people in the academic world because they really they might know the health industry very well, they might know basically finance very well, they might know marketing very well, but they're really not technologists and they really haven't handled large volumes of data to be able to fit in with your needs. So I think that's where our primary challenge is, but I think the other three areas we are able to address quite effectively.
Sure. So, I mean, I want to call out two things. Okay, one is many data science problems or data analytics problems are also change management problems. Okay, because you might have built the best model using the best algorithms with the best possible understanding of the business, but there is still a challenge in getting it implemented, right? Just like how strategy reports can just stay on the shelf and not find the light of day. There is this whole thing, yeah. There's a whole thing about like you build fantastic dashboards or models, but people need to make decisions based on all of that stuff. So the other skill that I wanted to call it was that this whole change management and the ability to convince people, right, that you need to change your decision-making paradigm, right? That's a very important thing. So, and connecting it back to what Dr. Sen said, right? I think I know that several institutions are experimenting with this concept of visiting faculty or people who need not necessarily be deeply trained researchers or even educationists, right, in some sense, meaning that their educational model of the teaching might be different. They may not be PhDs, but infusing domain expertise through some programs like that might be a way out, right, to solve this problem. I know that there's one program that we at Latent View Analytics helped put together in India. This is a program that's jointly run by the Indian Institute of Management, Calcutta, the Indian Statistics Institute, and IIT Kharagpur, and they bring the business, math, and the technical. Actually, students spend one semester each, right, in each of the three campuses. I thought it was a very interesting model. I mean, I'm sure that several institutions are looking to experiment with one. I mean, universities like Virginia Tech and all can bring all of these within the same, from the same institution itself. But there'll also be opportunities maybe for visiting faculty to come in and help plug some of the gaps.
Okay, my next question is, why did you get into data and what do you do in data?
Sorry.
Why did
personally or?
No, your organization. Why did you guys get into data and what
Right.
do you guys do with data?
Sure. Yeah. So Latent View Analytics is a complete pure play analytics firm only. I mean, our entire reason for coming into being as well as continuing to be in existence is just data and analytics, because we saw the possibility of this this immense opportunity 13 years back. I mean, we've been around for 13 years. We're still a young company in some sense, but we saw the transition starting to happen, right, with better technology, but more importantly, everybody talks about how the cost of computing has come down and the speed of computing has also gone up. I mean, these are two things. I mean, we know that deep neural network approaches and algorithms have been around for 20, 30 years, I mean, or even longer, but 50 years, in fact. But what has changed dramatically in very recent times is that, first of all, there is so much amount of data that can be collected and organized in one place because memory is cheaper, and the ability to just collect the data and make it available across the globe for a global company is a lot less expensive, with cloud and internet and so on. And the second thing is that we have the computing power to be able to do the analysis on all of the data, right, and then actually take decisions very fast, so that if you're in a football stadium with 80,000 fans and there is an event that is happening there, and you can actually collect the tweet data or the Facebook post data of all those 80,000 fans, and then instantaneously take a call on what is the advertisement that should be shown on the big screen, electronic screen that's coming up there. I mean, so today the possibility is there just in terms of the memory and the computing power. So what we do with the data is really that, right? We are able to collect structured data. We are able to collect unstructured data as well. And these unstructured data could be anything ranging from facial expressions of people to Instagram posts or video or image data. And I think increasingly the possibilities will be there even in terms of data that could potentially flow from wearable devices or the Internet of Things, for example, right? I mean, so there's so much of data that's coming in, and what we do is try and make sense all of that data in the context of a problem that you're trying to solve. And this problem could be as simple as what I just said. What is the next advertisement that should be shown on that big screen, right, the electronic screen? Or it could be something as complex as, do I go down a particular diagnostic path for a person who's gotten admitted into the hospital this morning with a history of illness and symptoms and so on? Yeah.
Pradip, you also in data analytics, maybe a competitive latent view, but still, what made you guys enter? I mean, you are a founder of that organization, and what do you currently do?
Yeah. So so my background was I studied more of urban policy and used to build mathematical models of cities. Right. So how can governments take policy decisions based on math rather than more of whatever negotiations, etc. So and then, but no, I transitioned to saying, hey, can rather than building mathematical models of cities and employment and networks and all of that, can I build mathematical models of businesses and markets and customer interactions and so on? So that was my foray into this space. And then I was during my first 5-6 years of consulting, working with a variety of companies across the world, one thing I realized was, oh my God, this has a lot of potential to change the way organizations conduct themselves, the way decisions are made, etc. Along the way, I met a professor who was doing his research, and in addition to his research, was also consulting, as part of academia. He was at MIT, and then we said, hey, I think there's a gold mine of an opportunity here for someone to come in and make a significant impact in the way organizations make decisions and go about things. And that was the start of how we started Tiger Analytics. So today we work with enterprises across the world, working on, when enterprises function, you can imagine they generate a lot of data, starting, any operations, you see, IT has been there enough, and IT systems are capturing a lot of data, starting from sales, marketing, variety of operations, from manufacturing or supply chain, merchandising, anything you call. Now, how can you use this data to get better at what you are doing, increase your top line, get more efficient, optimize things, everything. So it's over a period of time. So today what we do is we work with several enterprises and help them with their data analytics journeys.
Pradip, one of the organizations you are part of, you've come up with the false data, and you've actually patented how to predict false in the old. You've actually filed for a patent. How did that happen? I mean, obviously you found some data to do that, but how did you start doing that?
It all started off with a question. It started off with us saying, how can we either prevent further harm or improve the outcomes and the quality of life years for those that have sustained a fall? And one thing led to another, and then it started the snowball effect, and that's how we got involved with from linking the data from the hospital with a device that could collect that data.
Okay. Now coming to the professor, now all these guys talked about how they do business. What made you specifically run a data analytic program?
Ooh, that goes back a long time. Okay. What you are doing today is really not new again, and it's just evolved over the last 40, 50 years. When I first started off not in academia, actually I was in IIM Bangalore at that time, and we were basically, looking at management information systems. And the idea was, even at that time, that we need to move away from data processing to MIS. And the idea was that we need to not only just collect and create data for transactional systems, but we take this data and use it for decision making. And that's precisely what you're talking about even today, basically. So what we did 30, 40 years back is still the same today. But what has changed is the volume of data that is being created, the technologies that are available to process this data, and the focus is still on decision making. Essentially, whether you think about it, what you are doing and what you are doing and what you are doing, it's all about decision making. I mean, even basically, face recognition is also decision making. What you're getting is an image, and you have to essentially make a decision whether this image belongs to Tarun or does it belong to someone else. So, given that, and of course, my background is my PhD was in MIS, so it was a natural transition to move into this area. But at the same time, based on what I've seen in the last 25 years, this is not the end of it. You will see something else coming up in the next 5 years, and it may not be called data analytics. It'll probably be called something else.
My last question was to ask you, should VT follow a holistic curriculum? I think you've already answered that, so it's no point me asking you that question. I'm on 45 minutes almost. Okay, I must say thank you to Padu and also Priya for giving me this privilege to be your, I'm humbled by being your moderator, and thank you very much for following all the rules, unlike television in India. Thank you very much.